Assalamu alaikum viewers, welcome to my channel SK Electronics. Today's lecture is on the topic resistance. Literal meaning of resistance are an act or instance of resisting, meaning the capacity to resist something. Let's see the definition. Resistance is a measure of the opposition to current flow in an electric circuit. The second definition says property of material to oppose the flow of electrons through conductors is known as resistance. First definition, we can conclude that opposition to current flow means that it actually controls the flow of current in a circuit. From second definition, we can conclude that it is basically the property of material which opposes the flow of electrons. Let us see an example. When there is a high resistance, less current flows and number of electrons passing are less, and also the speed is low. On the other hand, when there is low resistance, more number of electrons flow through the circuit and also their speed is high. As a result, high current flows through the circuit. Now let's see this illustration to deeply understand the term resistance. This color represents the atom of substance. Frozen color represents the electron. There are two electrons, one is inside and one is in space. You see that when force is applied on these electrons, the electron in space could easily move forward because it observed no obstacles and was fast. The electron inside conductor experienced different obstacles along its path. That is why it took larger time and covered more distance. And these obstacles are actually according to the geometry of the material. What is the concept behind? To understand the matter, let us take example of metallic substances. There are a number of free electrons moving randomly in the crystal structure of a metal substance. When a voltage is applied across the resistance, due to the electric field, the free electrons drift from lower potential to higher potential in substance. During drifting motion, the free electrons continually collide with atoms of substance, and this phenomenon prevents the free motion of electrons, and this causes resistance. Resistance depends on the geometry of material and the material itself. Different materials possesses different geometry and hence different resistance. Here I have shown examples of copper and aluminium. It is clear from the images that their geometry is different. Due to this change in molecular arrangement of materials, electron experiences different geometry in every case. As a result of this difference, resistance is changed. Mathematically, resistance is equals to rho L over A, where rho is specific resistance of material, L is the length of conductor, and capital A is the area of conductor. Here I have shown the dummy arrangement of copper and aluminium. Rho is different for both copper and aluminium. This is the length of conductor and area will be length into width of the conductor. Unit of resistance is ohms. Definition of ohms is as follows: when an electric current of 1 ampere passes through a component across which a potential difference of 1 volt exists, then the resistance of that component is 1 ohm. Mathematically, 1 volt over 1 ampere is 1 ohm. Ohms are named after George Simon. He was a German physicist who studied the relationship between voltage, current, and resistance. In the circuit, you can see when there is a 1 volt difference and 1 ampere current, then 1 ohm resistance is present. Different prefixes are used for very large and a very small value of resistances. Giga for 10 raised to the power 9, mega for 10 raised to the power 6, kilo for 10 raised to the power 3, milli for 10 raised to the power minus 3, micro for 10 raised to the power minus 6, and nano for 10 raised to the power minus 9 ohms. Resistance is measured in ohms and is symbolized by the Greek letter omega. Now let's discuss the resistance of different materials. They are in broad 3 categories: conductors, semiconductors, and insulators. Conductors are those materials that offer very little resistance, where electrons can move easily. Here I have shown materials in raw form: silver, aluminium, copper, and gold. Semiconductors are those materials that offer moderate value of resistance, which means that resistance is neither very high nor very low. Examples are germanium and silicon. When phosphorus is added to silicon, a free electron is available in the molecule against each phosphorus atom. Due to movement of these electrons, current conduction is possible, as visible in the figure. Insulators are those materials which don't conduct electricity, that is, they offer very high resistance. Examples are rubber, paper, glass, wood, and plastic. These are examples of insulators. The points to remember from this lecture are as follows. Resistance is the property of material to oppose the flow of current. It is measured in ohms and represented by omega. The formula for resistance is rho L over A. Our next topic is effect of temperature on resistance, which we will discuss in the next video. Thank you very much for watching. If you like this video, give it a thumbs up and subscribe my channel.